Bismillah. Assalamualaikum and good morning, everybody. So this week we're going to cover intersections, and the notes for this week is extracted from Arahan Teknik Jalan 11-87, which is for at-grade intersections. So basically there are two types of intersections. The first one is at-grade, meaning that it is non-elevated. Everything as happens at surface height. And the second type is interchange. Okay, so you can see that it gets very complicated when we start dealing with interchanges. It is grade separated. Okay, so in these notes we are going to cover only at grade intersections. Okay, because that's the most basic and that's the most popular type of intersections that we're going to face. So it is one of the most important part in our road system. Okay, because it governs the capacity of our road. Even though if our link is performing in a good, have good level of service, if our intersection performs badly, then the entire network will be affected. So it is a combination between capacity and level of service of the links and the intersections. So the term intersections refers to both intersections and junctions where two or more roads cross or meet. Okay, there are four basic types of intersection maneuvers. Okay, basically diverging, merging, crossing, and weaving. And it can be further classified, okay, the movements into elemental and multiple. Okay. Elemental movement meaning that the movement is more or less less than two lah. Maximum of two movement. Okay, so it's either diverging to the right, diverging to the left, or mutual left and right, elemental, and merging and also crossing here. Whereas for multiple maneuver, you have more than two movement. So multiple diverging, multiple merging, and multiple crossing. And the most, in my opinion, the dangerous movement is weaving. Whether it is elemental or multiple, weaving is very dangerous. We try to avoid this type of movement when we are designing any intersections. Okay. So the number of potential conflict points when we are analyzing safety of an intersection, we will measure the conflict points. So the number of conflict points will depend on the number of approaches to the intersection and the number of lanes. Okay, if you have uncontrolled intersections, meaning that all movement are allowed, so you have more conflict points. So this is an example of a three-way intersection that has 9 conflict points. If this intersection is signalized, then the number of conflict points are reduced significantly because at one time there are only one or two movement that is allowed. So you eliminate lots of conflict points. Once the intersection is not signalized, then the conflict points is going to be quite a lot. So compare that with the four-way intersection, you have 24 conflict points. Okay. So it happens once in my life. I was involved with this kind of study was in UM. At that time, the intersection in front of our faculty, the intersection that leads to the PJ gate and to the library. At that time, the configuration is a little bit different and it causes quite a lot of accidents. So I was asked by, at that time is Professor Rehan, the head of Transportation Research Group, under the instruction of the UM management. We need to study what are the conflict points and why does that intersection is very dangerous. Okay, so we managed to reduce the number of conflict points and try to uh, rearrange the geometrics of the intersection. When I was collecting the points, even when I was collecting the apa tu survey volume and the capturing videos and photos at the intersection, an accident happens. A car was turned over. Okay, they hit each other. There's a collision and it was turned over. Unlucky for me because I didn't got it on camera. Not unlucky, something dangerous, but I didn't get it on camera as a proof. But I only get the picture of the accident afterwards. Okay, so the idea is try to minimize or eliminate the conflict points. Okay, so you can eliminate the conflict points by changing the configuration into from apa tu unsignalized to signalized, or you can have channelizations. Channelization meaning that you construct here, like here, islands, traffic islands, making that individual movements are very well defined. Okay, so that in a way will affect the number of conflict points and how people behave at intersections. Okay. So types of aggregate intersections, we have three types: unchannelized and unflat, flat and channelized. Three main types. So unchannelized and unflat, meaning that this is the most basic intersection, meaning that if you have two lanes on this side, two lanes on this side, there is no extra auxiliary lanes. Okay. So many local streets remain unchannelized for economic reasons. Economic and also, oh sorry, economic and also sometimes space lah. We don't have the space, okay, especially in in urban areas. So in such cases, traffic can be controlled by signals or regulatory signs such as stop or give way. Every intersection must be controlled. Okay, the minimum control is stop signs or give way signs. Okay, if you don't have space for channelization, but you still need good control, then you need to upgrade to uh, traffic signals. However, the warrant, if you recall from previous semester, you have an assignment on traffic lights warrants. Okay, that warrant must be satisfied before you actually decide to install any junction with traffic light. Okay. Anybody can answer me why the traffic light warrant is important? Why do you need traffic light warrant? Okay lah, in terms of volume lah, why do you need specific volume uh, before you are warranted to install traffic signals at an intersection? At an intersection. Anybody can answer me?
Economic reasons?
No. Why do you need to achieve a certain volume of movement before you are warranted to install traffic signal? Okay, the answer is if you don't have enough volume, um, you will have people waiting at especially when the traffic light is not uh, actuated by movement or by volume, by apa tu, vehicles passing. You'll have people waiting, vehicles waiting for nothing, meaning that you don't have enough volume. So people will have to stop and then wait, whereas there is on the other side there is no movement. So that in turn will cause a disrespect to the traffic light. Okay, traffic light is a form of law that should be respected. But if the system is not good, people think that they are wasting their time waiting there for nothing, people will lose respect for the traffic light. So that is something that we do not want to embed in the minds of the public. Okay, so yes, correct. Traffic signals is for heavy volume. Okay, that's why you have the warrant. Why you should meet a certain volume, only then you can install traffic light. Okay. Okay, next is the flat intersections. Okay, where you have some auxiliary lanes here, okay, to help, in a sense, to move lah, turning movement. Okay, so a flat intersection is a simple unchannelized. Okay, meaning that it's just an extra auxiliary lane. Okay, such as speed change or right turn lanes, meaning that you can decelerate here using this lane before you turn left, for example lah. Okay, speed change lanes allow left or right turning vehicles to reduce or increase speed when leaving or entering the through road. Okay, so you can call this lane as, this is an auxiliary lane, but this type of lane is specifically is deceleration lane. If the other side here has another auxiliary lane, so you decelerate here and you turn left, enter the other road, in the other auxiliary lane, and this one over here is going to be the acceleration lane, where you need that lane to accelerate and join into the mainstream of the traffic over here. So you have two types of auxiliary lane, which is the deceleration over here and acceleration over here. So right turn lanes permit through vehicle to pass on the left side of another vehicle waiting to complete this one, right turn lane. Sometimes it is called as right turn storage lane. Okay. So a channelized, meaning that you have a specific channel over here. Okay, this is a right turn lane. A channelized intersection is where the path of travel for various movements are separated and delineated. Okay, separated lah. So raised traffic islands, raised markers, and painted markings can be used for channelization. You have separated channel here, and then you have raised island over here. Or this island can also be painted lah. Okay. So a roundabout is a channelized intersection where traffic moves clockwise around a central island, and the layout of the intersection should be adequately illuminated by street lighting or defined by pavement reflectors. So it is very important, especially much more important at junctions, that you need pavement reflectors, signage, and very good lighting. Okay. So this is an example of a channelized intersection, okay, where you have a very large island there. So the problem with this type of intersection is that you need lots of space. Okay, it is very efficient, but you need lots of space. So this is a channelized junction, T-junction. So you can see that this is the left turn lane, and this is the right turn storage lane. Right turn storage lane. Okay. So factors influencing intersection design. At grid intersection present a driver with several points of conflicts. Okay. Again, it has lots of conflict points. So the aim of intersection design are to improve traffic flow and reduce possibility of an accident. Okay. So the principal factors are traffic volume and characteristics. Okay. First, you need to know what are the volumes and what are the compositions, okay, of the traffic, topography and environment, the gradients, and the environment lah, the buildings, okay, around the junctions. How much money do you have, and human factors. Do you have lots of pedestrians or not? Okay, if you have lots of pedestrians, then definitely you need to have pedestrian crossing lah. Okay. If you have pedestrian crossing, then you need to incorporate the 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 one that you have learned in 3003, isn't it? You have phasing for pedestrians, for example. Then you need to incorporate those phasings. Okay, traffic volume characteristics. Intersection accommodate comfort and safety uh, at design peak traffic volume. At, okay, should be comfortable and safe. So the needs of commercial vehicles need to be considered. If it involves commercial vehicles, then you need to know the turning radius. Okay, we will get into that afterwards. The turning radius of vehicle, of the at the intersections. So you want to have the geometrics, okay, the radius at the here, the intersection here, adequate for larger vehicles to turn. Okay. So considerations also should be given to operating speeds and turning path requirement. So turning path and turning radius is a different thing. Turning radius is just the radius, but the path involves the overhanging area, meaning that even though the radius is, let's say, 10 meters, but the path that the vehicle is going to sweep is going to be a little bit larger than that. Okay, so you need to clear all of the that area, okay, that is within the turning path. It need to be cleared. Okay. Type of traffic control and need of pedestrians. Again lah, need for pedestrian, buses and safety. So topography and environment, the location and design of the intersection will be affected by the factors again, alignment and grade. I believe by now you already very well aware the importance of alignment and gradients. Okay, so especially when you are actually connecting your road, your new road in your project to the existing road. Okay, so now you can see that you are actually forming two junctions. So whether the points that you have chosen is suitable for a junction or not, then it's a different story lah. We haven't analyzed that. Maybe you can try to look at that your project. For the time being, I don't require. There is no requirement for you to submit junction design, but it's good for you to try to imagine. Okay, will the does the point that you have chosen give you a good intersection or not? I believe one of the intersection is very close to a bridge because not your bridge, but the existing road is actually crossing a river, isn't it? And that, in that case, definitely at that point you are going to have a bridge. So is it safe for you to create an intersection very close to a bridge or not? Okay, so your first design, I think your first alignment is going to be an alignment that has a bridge, meaning that you have to construct a bridge. And the ending of your alignment will end at very close to another bridge, existing bridge on the road. Is it road A or road B? Road B, I think. Okay, so you can think about it. Is it good to have a? Is it allowable to have a junction over there or not? So you need to consider the side distance. But it's okay. This is just for you to check lah. Okay, I'm not going to uh, give points, okay, or deduct points because of the junction. Okay. So the need to provide for drainage. Okay. Again, you don't want to have rainwater ponding at your intersections. So you need to have a very good drainage lah, saya cakap The gradient there must be good. And the extent of interference with public utilities. Okay, this you cannot avoid, especially when you are working at urban areas. If you are trying to upgrade any junction, definitely you need to definitely if you are going to use a proper punya upgrading. Okay, sometimes I've seen authorities, they actually change the layout of the intersection but they didn't want to move the utilities. The lighting, they keep it there. All the electrical wiring is all were kept in place. So that will cause a very funny alignment at the intersection. Okay, because moving these utilities is very expensive. It's easier for them to just widen and then repaint the road line paintings, but to move the utilities, then that is big business. So they try to avoid that. Okay. Proper access and presence of local features are both man-made and natural. Okay, need to take into account in urban settings. You need to take into account the buildings lah surrounding the intersections, and also lastly, the amount of money that you have. Okay, variation to existing intersections should be justified to commensurate benefit to traffic. So, do you really need to upgrade? Okay, how much money that you are willing to spend and how much good will it bring to the public? If it is concerning safety, then there is no other excuse. You need to spend money lah if it is safety. And then human factors. In an intersection design, driver characteristics should be considered. That drivers tend to act according to habit, tend to follow a natural path of movement, and maybe become confused when surprised. Although those characteristics sounds like a characteristic of a horse, but that is human nature lah. Okay, we tend to act according to habit and tend to follow natural path. So that's why when designing an intersection or road, especially in an urban setting, an engineer will have to become an architect. Okay, so if you are designing a house, you have an architect to design the environment of the house, the look of the house, so that it is natural. It does not confuse people. So engineer's job is just to design the structures. Okay, follow whatever that is being outlined by the architect, and everything is fine. But highway engineer, you need to consider these kind of things. Okay, human behavior, how not to confuse people. Okay, how to put the signboard so that people will clearly understand what's going on. Yeah, so that is the difficult thing about becoming a highway engineer in an urban setting. Okay, so these factors make it essential that a driver is made aware of the presence of an intersection. This is the most important point lah, meaning that the drivers must know that in front of them is going to be an intersection in maybe 50 meters, okay, 30 meters, like that. So the driver is aware that the vehicles is within the approaching the intersection again lah, meaning that they are closing to the approaching to the intersection. So has the confidence in the cost required to negotiate the intersection correctly and safety, meaning that they can see what is on the other side, so they know that they are going to be safe. It's not like that the intersection is being covered with you cannot see because there are buildings, there are phone booth or bus stop, okay, on the way, in the way, hiding the vehicles coming on the other side. So they need all those need to be clear so that the drivers have confidence to negotiate the movement. Encounters uniformity in the application of traffic engineering device. This is basically not much of a problem lah, because we are mostly referring to the same specification. So the traffic engineering device in Malaysia is more or less standardized. Okay, so a driver is allowed adequate reaction and decision time. So not just the stopping sight distance, okay, of a vertical curve or horizontal curve takes into account the decision and reaction time, but the design of intersection also will require reaction and decision time. So 3 seconds between decision is desirable minimum. Okay, so you are for horizontal curve, vertical curve, I think it's 2.5. Now for intersection is 3 seconds. Safety is a prime consideration in any intersection design. safe design is based from the following principles. Reduction of number of conflict points. This is what you should try to do first and foremost. Okay, try to reduce the conflict points. Minimize the area. Okay, I'll show you another diagram on the area of conflict points or separation of conflict points. Ni saya tak ada contoh lah pula. Tak apa. Giving preference to major movement and control of speed. Control of speed normally is controlled by apa tu? Devices, road humps or apa tu rumble strips or just apa tu signboards. And provision of refuge area, traffic control safe devices and adequate capacity. Refuge area meaning that you have islands over here so that people want to cross, pedestrian wants to cross nearby this roundabout. For example, you have a zebra crossing and then you have an island for refuge. Okay, and then you have another crossing over here. Okay, and so also the definition of path to be followed, meaning that it should be delineated. Okay, should be painted. The road line painting must be clearly painted. Okay. Next, you have stagger intersection. Okay, this is in a case where you have angle of the intersection is less than 70. Okay, less than 70 degrees. So it is advised that if you have this kind of configuration, might as well you just move it like so. So instead of having less than 70 degrees, then you have a slight curve here. So this is a little bit better lah than having this angle. Okay, so, but you need to determine the spacing here. But we don't have the calculation right now lah. This is just theoretically lah. You understand that you can move the conflict points in this way. Okay, so this is the area of conflict. Okay, when you have 70 to 110 degrees, this is the size of conflict area. Once it is offset, then the conflict area will expand. You have a larger conflict area. And once it's skewed less than 70, the conflict area is even more dangerous. So this is definitely unacceptable. So you can see the effect of angle here to the safety. Okay, so this graphically is shown here. All right. So generalization and realignment can both reduce conflict area. Okay, major movement, preference should be given to major traffic movements, and drivers who travel for long uninterrupted distances at high speed will be slow to react to sudden change in alignment or to the entry of high-speed vehicles from a minor road. Meaning that if you are designing your alignment, okay, you have already been, the drivers has already been driving for maybe 10 kilometers. And in that 10 kilometers, more or less, there is no change of gradient, there is no much change of horizontal alignment. So they are traveling at quite a high speed. So before you introduce any junctions or intersections to those types of roads, you need to change the geometrics a bit, and you need to have signboards warning the drivers that they are approaching an intersection. Okay, maybe in 100 meters, 200 meters, they should be made aware that they are approaching an intersection. Okay, so that they'll have they will be aware lah. Their reaction time is going to be normal. Otherwise, if they are not being told that there is an intersection, then the speed and the reaction time will be inadequate. Okay, for him or her to react. Okay, minor movement should be subordinated to major high-speed movement. Okay, of course lah, you have two roads. Normally, one road is major, one road is minor. So minor movement should be subordinated to the higher speed movement. And adequate warning on minor approaches should be provided. Control speed. So operating speed of traffic through an intersection depends on the alignment, again, environment, traffic volume, and composition, extent of traffic controls, number. Okay, this is more or less the list of what I've explained to you just now. Okay, traffic control and geometric design. So in intersection design, the possible use of control devices and other road furniture should be considered. Can be considered. Most of the criteria for geometric designs are common to both signalized and unsignalized intersection. And design of an intersection to be controlled by signals can differ significantly. Okay, for intersections that have it is signalized, the side distance can be a little bit less compared to stop sign control intersections. Okay. For example, double right turn lanes, which aim to shortening storage lane, okay, here, double right turn lane, are effective only at signalized intersection. As at unsignalized intersection, the number of vehicles which can depart from the queue is dependent on the frequency of acceptable gaps. So there is no use for you to provide double right turn lane here if the intersection is unsignalized, because this is not a good example actually. You should have another apa tu? The diagram here. You should have another traffic flow coming here, because this movement will depend on the movement on opposing movement. Okay, because it is uncontrolled, so the people that are queuing here need to observe the gaps in the flow over here. Okay, so it is more or less depending on the gaps. Okay, so double lanes does not make much difference. Acceptable gaps. Okay, left turn lanes this side and signalized intersection requires additional consideration, as queuing vehicles on the leftmost lane waiting for the green signal would block entrance to the left turning. So the length here should be designed appropriately. Okay, otherwise the spill here, the queue here can spill to the to this lane and blocking people that wants to move straight. Okay, so this is much less significant in unsignalized intersection. So this is for signalized lah. Okay. Capacity. Design must provide adequate traffic capacity throughout the expected life of the intersection. This may involve the design separate construction stage before the ultimate development, meaning that you can design according to the projected number of volume of vehicles that is going to be used in that be using the intersection. For example, you estimate the AADT, okay, the movement volume at one particular intersection in 5 years is going to be X. So you design that intersection to to be sufficient for year X. But then tadi saya cakap macam mana? Year X ke apa ke? But then you know in 10 years or 20 years time the traffic is going to grow. So you make the allocations, okay, at that intersection so that it can satisfy the demand for 20 years. But for the current time, you only construct for the demand of 10 years, for example. So you have the space available. You are designing the intersection. The reserve is very big, but you only construct a small intersection because it's only adequate for 5 or 10 years, not 5 lah, 10 years. Okay, but you already have the space to expand the intersection at a different stage at a different time. Okay, so that is what it means by separate construction stage. Okay, efficiency of major roads in terms of capacity, speed, and safety depends on the number and type spacing of intersection and median openings. How frequent do you have intersections along your road, and how frequent do you have U-turns or median openings? Median opening normally is U-turns lah, is for U-turn. So intersection should not be located at sharp horizontal curve, steep gradients, or at top of crest vertical curve or bottom of sag vertical curves. Okay, I'm sure now you understand what I mean by top of class vertical curve and bottom of set vertical curve, kan? So you can imagine lah what will happen if you have an intersection at that points, those points. Future coordination of traffic signals should be carefully considered in determining intersection spacing. If the spacing, the distance between one junction to another junction is very close, if the volume is low, then it's okay. It is not coordinated. But if traffic volume is very high, then you need to have coordination. Although in Malaysia it's very rare lah to have coordination between two close by, very close traffic lights. But that's the best thing to do. I don't know. The cost is quite high lah to coordinate. But it's something right to do, isn't it? Might as well you spend money a little bit more so that you get it right the first time, rather than installing two traffic lights and then finding out that it doesn't work. Okay. Tapi difficult lah. Nanti you kerja you tahu lah macam mana you nak how to deal with this kind of things and the type of nonsense that you will be facing. When, for example lah, if you one day when you are working, you'll be using the trade generation manual 2021 or 2022. You'll find that some of the data are basically useless in that new manual. Okay, so because this involves a lot of parties, so you can see that, alamak, actually record tak boleh cakap lah. Okay, tak apalah. So just made aware some of the data in the coming trade generation manual is probably good for nothing. Okay. Okay, spacing of intersections. Spacing of intersection depends on factors such as weaving distance and storage length required for queuing traffic at signalized intersections and the length of right turning lanes. Okay, what they is trying to say that the distance here lah. This is very difficult to achieve actually. Very difficult to achieve. If you try to measure, then you find out whether it is okay. Yeah, let's try to measure. One minute. So this is Jalan Profesor Engku Aziz. This is PJ Gate. And this is Intan. Let's measure. So the distance here is 500 meter. Okay, ngam lah. 500 meter is okay. Okay, what road is this? Jalan Profesor Engku Aziz. Okay, just remember 568 meters. Okay. So Jalan Profesor Engku Aziz is urban. Is it an expressway? No. Is it an arterial? No. Is it a collector? Yes. So what is the spacing? V times 2 times N. Okay. So what is the design speed for that road? I pun malas nak buka kan. Katalah berapa? 60 ke? Katalah kita be conservative lah, 80 lah. 80 times 2 is 160 times number of lane in one direction. So So 180 times 2. 2 lanes ke 3 lanes lah? 2 lanes kan? 180 times 2 is 360. So what we have now is 568. Okay, so meaning that it is adequate. Okay. If the design speed is 60, 60 times 220, 120, memang panjang lah. Kita memang meet the requirement. But when you actually measure the other roads, some of them will not satisfy this requirement lah. Especially in rural areas actually. Rural areas, the spacing is very big. If V times 10, for example, if the V primary road is 90, the speed is 90, you just times 10, 900 meters, you cannot have any junctions. Okay, channelization. It is not practicable or desirable to standardize the design of channelized, but you need some, to a certain extent lah, some guide. It's only a guide. You cannot standardize because the configuration, the geometrics of each intersections are different. So you cannot generalize. You only can have a guide. So the layout for a particular site depends on traffic pattern, volume, okay, area, which is economically available for improvement, meaning that the space lah, topography, pedestrian and parking, and the planned ultimate development of the neighborhood and the layout of the existing road, meaning you need to take into account what is going to happen around the intersection as well. What types of development. So as well as separating movement, channelization is used to reduce the general area of conflict because you are actually separating the movements. Okay. Merge traffic stream at small angles and control the speed of traffic crossing. So this is Seagull Island, for example, meaning that you are splitting this movement, right turn before it joins the bypass lane here. So you are splitting this one, the movement. So in this type of configuration, you can have a separated phase for this one, the junction, and then at the same time, this traffic flow here resume as usual lah, as if there is no intersection over here. So provide a refuge for turning of crossing vehicles, okay, ataupun prohibit certain turning movements. If you have island like this, you definitely cannot make a U-turn. Okay. Improve the efficiency of layout, signalized intersections, protection for pedestrian because pedestrian can cross the road and stay on the island over here. Improve and define alignment and provide locations for the installation of traffic signals. But you need to bear in your mind that channelization is actually an obstacle. It is good, but it is an obstacle. So you cannot use it excessively. That will result in an unwarranted obstructions on the road pavement, unnecessarily restricting parking, and cause problems, maintenance and drainage. Because everything, you have curbs. Okay, so drainage of rainwater is going to be very difficult. Unless you have underground drainage and all that. But most of the time, they don't have it. So if you have lots and lots of channelization, the drainage is going to be a problem. It also can create confusion if you have too much curbs, okay, on the road. Design control. Okay, sampai 45, slide 45 nanti kita stop sekejap lah. Okay, all intersections should be designed under assumption that one intersecting road has priority. Okay, you always assume that one road has priority. Before that, I need to say that I think this diagram is wrong somehow, kan? This should be the priority, the major road. But the moment it seems that it is providing stop line over here. I don't know why. Okay, I need to change this picture over here. Okay, the priority road will normally be that which of a higher design standard. Okay, normally this main road, major road, will have a higher design standard, and the junction here is going to be a lower one. Alright, then the priority, if the two roads are of the same standard, okay, like maybe in your case, R3 and you design similar road, with same specification of R3, so the roads are of the same standard, then the priority road shall be the one that has highest traffic volume. Okay, then that is the priority road. Usually, one road is higher and the other was a bit lower. So you know that the higher one is the major road. Okay, priority control in T junction and staggered junction. The priority road shall be the through road. T junction shall be the through road. In the main traffic flow in a T junction, yours is T junction. Okay. If the main traffic flow in a T junction is on the stem, if this part is the main major road, then a change of layout should be considered. Meaning that you need to have a to make sure that the speed here before it joins the smaller road, the speed must be reduced significantly. So the two roads of the intersection are normally referred to as major and minor road. This is another type of control, left in, left out, or lie low. So left in, drivers coming from here, vehicles coming from here, turning left in, and vehicles going out, left out, going to the left out, going to the left in. So left in, left out. So there is no movement from the other side of the road is allowed. Okay, only left in, left out. Traffic. Capacities of minor intersections in general sufficient to meet expected traffic volumes, and detailed traffic forecasts are definitely not required. Okay, if the intersections are very small, we normally do not need traffic forecast. Intersection where major roads carry a large volume of through traffic, or where the two roads carry nearly the same volume. Yeah. May, on the other hand, have insufficient capacity for crossing or turning floors, for which particular types, ini saya ambil daripada arahan teknik ni, the capacity, the factor of capacity increasing measure may have to be taken. Okay. Senang je lah ni kan. Kalau tak cukup capacity, then you need to increase uh, uh, the capacity lah of the road. Normally, increasing capacity meaning that you are adding more lanes, kan? Okay, sekejap. Detailed traffic forecast for such intersections must be carried out in order to provide the necessary data. Okay, ni kerja traffic consultants lah. If you are working with traffic consultants, some consultants they do it themselves, gathering traffic volume data. But there are specialized consultants that only do this type of work. They only do traffic counts. So these are the people that is very much needed lah. Okay, because they are doing the difficult, not difficult lah, the dirty job. They need to go to the site. Okay, they need to sit there and count the traffic. If the requirement is 16 hours count, I was in charge of traffic count, not once actually, in Jalan Lok Yu once, and then Jalan Pandan Indah once, and in Shah Alam. In Jalan Lok Yu and Pandan Indah, the traffic count is 16 hours, meaning that you should start 6 a.m. in the morning and end at 10 p.m. at night. Okay. If it starts 6 a.m., meaning that you have to start preparing for the traffic count before that. For more or less 5:30, you're already at the side of the road. Okay. So at that time, we don't even have the large umbrellas. Okay, I just contact IPK, Selangor, just to borrow umbrellas from traffic police. So strangely lah, the traffic police say, okay, yes, you can borrow our umbrellas, but make sure that it is safe and everything. So I borrow umbrellas, so I rented vans to carry all the enumerators, the people that is working, okay? So I drop them at respective intersections. Everything must be done before 6 a.m. because 6 a.m. sharp, they need to be starting to count. Okay, so it's such a difficult job lah. Such a difficult job. It's not difficult, it's apa tu? Leceh lah. Leceh punya kerja. And then sampai pukul 10 malam. You cannot stop. 16 hours traffic count. Okay. Kalau enumerators need to go to the toilet ke, dia nak pergi solat ke, if they want to go to pray or going to the toilet, I'm the one that have to count for them lah, cover for them. Okay. Detailed traffic forecast shall provide hourly traffic flow in all direction of the design year. Okay. So this is an example of excerpt for particular TIA report. So this is for your year 2033. Okay, you have the current year count. Okay, at junction JC3 here, you know that how many volumes vehicle turning right, how many turning left, how many going straight, how many turning right here for the current year. You know the projection, the percentage of traffic growth in that area. So from that, you can estimate the the volume of traffic flow in the horizon year, okay, in the future. Okay, so you can know lah what is the impact. Okay, what will happen to this intersection 20 years down the line, for example. So this is the estimation of delays, level of service. So you can see here future peak hours count, year 2023, AM peak for JC1, JC2, JC3, JC4. So what is the level of service for all these junctions? Some are D and E, some are A. So some here over here, it is F. So you can see here, year 2023 without development, and this is with development. So they are estimating the level of service of these junctions after the development, meaning that a developer is proposing, let's say, a shopping mall at a location. That shopping mall will have an impact to the nearby junctions. So they measure what is the current condition of the nearby junctions without the development, and if they build that shopping mall, extra traffic will be attracted to that area, thus increasing the number of volume, the volume of the vehicles. That extra volume will decrease the level of service. So you can see the difference here. Okay, DE. This is D. This is AM peak. This is PM peak. So from D it becomes E. Okay, here from C becomes E. B it becomes F. So you can say that that development reduces the level of service of these junctions. So what can be done to make sure that you can build the development, but at the same time these junctions do not suffer. So they estimate here with development and mitigation. So they have provided alternatives. What should be done to this junction over here, so that with that mitigation, now the 2023 with development and mitigation, the level of service instead of E, it is B, and instead of F, this one is C. Okay, I hope you understand lah, yeah. This is actually covered in 4015. For those who have already taken 4015 last time, I think it's very clear for them lah. Okay. So design year shall be 10 years after construction of an isolated intersection. similar to the design of the rural way. A stage construction, ni stage yang that I mentioned just now. 5-year traffic requirement is acceptable, meaning that you can have the construction staged at every 5 years. However, the land requirement must be sufficient for the full design year, meaning that you have to prepare the area. The reserve area must be enough for 10 years. But for construction, you can construct until 5 years requirement only. Okay, then after the 5 years has lapsed, then you upgrade the junction to be fully designed. So design speed of the major road through the intersection should be similar to that on the open section, if possible. Again, meaning that if the road has 80 kilometers per hour design speed, the intersection should be designed at 80 kilometers per hour as well. However, all at grade intersection are not safe at design speed exceeding 90. So you cannot design in an intersection with 90 kilometers per hour design speed. So for design speed exceeding 90 km per hour, you should consider to upgrade to interchange, grade separated junction lah, intersection. Okay. So vehicles on the minor road can be assumed to approach the intersection at the design speed of the road, and drivers should be able to perceive the intersection from a distance of not less than stopping sight distance. So ini dia punya distance yang mesti clear the sight distance for intersection approach. So this is the design speed, this is the signal control, this is for signal, this is for stop control. So signal control, the sight distance is longer compared to stop control on minor road. Nanti sekejap. Major road. Okay. This is not very clear. Normally what we use in Malaysia, currently lah, what I've been doing, I'm using Australian standard. I'll show you once. Mana tak ada pula. This one is Australian standard. Okay, tapi tak apalah. You just need to know this. This is very vague lah actually. Okay, the side distance for intersection approach. Okay, so kenapa saya letak gambar ni kat sini, saya dah lupa pula dah. I think this is to illustrate the topography, the connection. Tak apalah. Saya kena buang balik semula ni. Saya dah lupa dah. Okay. The next thing that you need to consider is design vehicles. So again, it is involving turning movements. Okay. So you have several design movements, be it WB50. This is wheelbase 50 feet, meaning that the length of the vehicle is 50 feet. SU, apa tu, sports utility ke? Saya dah lupa. Yang satu lagi ni P, passenger vehicle. Okay, so for rural, expressway, highway and primary must be designed. All junctions must be designed using WB50. For secondary, should cater for SU, and minor, SU and P, meaning that SU lah. SU sama juga. So these are the design vehicles for urban areas. So this is the turning radius for different types of design vehicles. So this is P design curve. P is passenger car. Okay, so you can see the actual radius. The radius of the center line here is 6.4 meter. However, the path of overhang is over here. So 7.75. So instead of providing 6.5 meter here, you should provide 7.75 because there's a segment of the car that overhangs beyond the edge of the pavement over here. So the minimum is 7.75 must be clear. So the same case with SU over here. You can see the center line here is 11.5 and the actual path of overhang is 13.21. So this is the most important vehicles because normally we will try to satisfy the need for WB. This is WB15. This is wrong. This is WB50 because the length here is 50 feet wheelbase. This is a typo. 50 feet wheelbase. Okay, so the path of overhang is even bigger 12.5, and now here is almost 14. Okay, that's 1.5 meters beyond the the center line turning radius here. Okay, so this is the dimensions for design vehicle. Okay, so P design is for local street intersections. SU design is a minimum for all road. Okay, we normally do not just satisfy the needs for P design. At least it must satisfy SU. Okay, the best if you can provide for WB 50, wheelbase 50. Okay, where design of such vehicle are warranted, simpler symmetrical arrangement of three-centered compound curves are preferred if smaller vehicles make up sizable percentage of the turning volume. So this is combining the the radius. Okay, so you have three circular arcs. Okay, so this is a different design if you want to combine three circular arcs. Okay, selection of intersection type. Okay, intersection type, you have several types: stop control, signalized, interchange, and roundabout. So the use of the different types here depends on number of vehicles. Okay, total of two-way traffic on major road and heavier approach volume on minor road, VPH. Okay, two-way traffic on major road and heavier approach volume, total. So if the total is 1005 and lower, it can be stop sign, stop control. Signalized between 800 to 5000 plus, 5500. Higher than 4000, you can start to consider for interchange. Okay, and roundabout is only convenient for until up to 5000 vehicles per hour. Okay, so I'm going to show you a video here of a poorly designed roundabout, but I need to for you to take note lah. This is a amateur video. So the language is a bit class. Okay, so just ignore the language. I just see at the problem, the engineering side of the problem. Okay, 1 minute. Okay. 1 minute. Mana saya nak tunjuk window. Okay.
Yang mencipta jalan di taman kawasan ni, yang buat benda-benda yang meraba-raba ni, kita tengok roundabout paling kecil dalam dunia ni yang mencatatkan sejarah ni, ini taman kawasan. Kita tengok macam mana saya nak U-turn. Kena pusing. Pusing.
Doctor, we cannot see, Doctor.
Oh, apa?
Only black screen.
Okay. Alamak. Sekejap ya. Nampak tak?
Just now, yes. But now, no. Okay.
Okay, semula lah. Boleh nampak sekarang Can you see it now?
It's on and off, Doctor.
Okay, what about now?
Now
Boleh
can, yes.
Yes,
Okay, yes.
Okey. Hari ni kita nak tengok kebodohan orang yang mencipta jalan di taman wawasan ni. Yang buat benda-benda yang berapa-apa ni. Nak tengok roundabout paling kecil dalam dunia ni yang mencatatkan sejarah ni. Ini taman wawasan. Kita tengok macam mana saya nak U-turn. Kena pusing. 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 Oh, tak lepas ada kereta dekat sini. Kita mundur reverse. Reverse. Tengok dekat sini ada kereta belakang tunggu saya. Tak apalah, punya kerja dah buat benda ni. Baru nak lepas. Inilah pihak berkuasa mana punya kerja ni. Bongok punya kerja. Tak sekolah. Ini baru kereta. Macam mana lori nak U-turn. Nak buat rombak kat situ. Tolonglah fikir sama.
Okay. Okay. To be fair, it's not easy. It is not easy to fit in the design in an urban setting. If you can see, you have in that video, you have pedestrians, you have bicyclists, you have all sorts of vehicles, and it's very tight. Okay, but the problem is, at least for the designer, when you have designed it, try to experience it yourself. Try to drive it. Try to drive over there with your own vehicles, again, before you adopt. And you cannot have, if you notice the parking space that is hindering the car to make a turn, it's actually an illegal space, because it is in a box. Okay, if you want to do that, you cannot have that space over there, definitely. So that means that design does not take into account whatsoever the radius, the turning radius whatsoever. So please avoid this kind of things lah. But this kind of things normally is not under the jurisdiction of JKR or large consultants. It is being done by municipal councils. Okay, but yalah, at least try to, they are trying their best. You can see all this traffic devices are all in place, but it is not suitable lah, senang cakap. Not suitable for pedestrians, not suitable for bicyclists. Okay, it's not even suitable for cars. Okay. All right. So this is the different type of intersection according to area. Okay, so expressway and highway and expressway, primary road and expressway, 100% you need to use interchange, IC. Okay, with the secondary road to highway, secondary road to primary, that is apa tu, signalized intersection or stop control. So SC here. So local to highway, local road to secondary, all you can control by stop control. But it depends lah on the volume. This is just a general rule. So this is for rural area and this is for urban area. Okay. Combination and coordination of coordination of successive intersections. Minor roads at close proximity create successive intersections on the major road. So they should be treated as follows. Local service road should not be linked directly to major road. Okay, this is I've already mentioned this previously, kan. It should be linked according to hierarchy lah. You cannot connect local road to major road. So local road should be connected to collectors and then linked to major road. Local street should not be linked to the major road near major intersections if you need to, especially if this is unavoidable, only left turning movement should be allowed, meaning that left in, left out. Okay, if you need to have intersection or junction lah near to major intersections. Right turns from the major road from the crossroad should be physically prevented. This is where I've shown you just now lah, lie low, meaning that from the main flow, it cannot turn right. You only allow turn left in and left out. When a new major road is being planned over an existing road network, coordination and adjustment of the layout and spacing would be created along the road must be done. Relocation of existing road and systematic control may be required. This is theoretically meaning that you should organize lah the spacing and also the the design of the layout for the intersections. Okay, let's take a break for banyak lagi tak? 50. Dah tak banyak ni sebenarnya. Take a break 15 minutes lah. Boleh 15. Okay, I'll get back to you in 15 minutes. Thank you. Okay, let's continue. All right, geometric standards for intersections. Horizontal alignment. Again, I think you already know this then. 70 to 90 degrees. So less than 70 is not desirable. Vertical alignment is desirable to avoid substantial grade change at intersection, or intersection where give way signs, stop signs, or traffic signals should be as flat as practicable, so that these sections can be used as storage space for vehicles stopping at the intersection. Okay, we try to have it as flat as possible. More than 3%, you should avoid to construct intersection. Where conditions make such a design unduly expensive, grade should not exceed. Okay, if you really need to, the gradient should not exceed 6% with a corresponding adjustment in design factors. Okay, we do not cover this part lah. A general principle is that the horizontal and vertical alignment of the major road, as well as its super elevation or crossfall, is unchanged through the intersection, that the carriageway of the minor road and the additional lanes are designed to fit that of the major road. Okay, so the crossfall, everything maintained as the same. Okay, and then it is designed to fit the uh, the crossfall of the major road. Okay. Next is the side distance. Operator of a vehicle approaching an intersection, a grade should have an unobstructed view of the whole intersection and the length of the intersecting road sufficient to permit control of the vehicle to avoid collision. Meaning that all intersections should be clear, especially for vehicle on the minor road lah, because they are the one that is going to be turning into the major road. And for the major road, the uh, the the space that should be clear so that they will be able to see the coming vehicle from the minor road. When traffic at the intersection is controlled by signs or signals, the unobstructed view may be confined to the area of control. It is advantageous on capacity grounds to increase where practicable sight distance along the major road by 50%. Meaning that we try to get it the sight distance as much as possible lah, so that you will be able to see the gaps between the vehicles on the minor or major road. If you are on the minor road, you'll be able to see the gaps between the vehicles on the major road. As for the sight distance of the driver of a vehicle passing through an intersection, two aspects must be considered. There must be sufficient unobstructed view to recognize the traffic signs, okay, meaning that you must be able to see the traffic signs, and there must be also sufficient sight distance to make a safe departure after the vehicle has stopped at the traffic line, at the stop line. When you have stopped, you must have a sufficient sight distance to see the coming vehicle, so that you be able to know, you'll know that it is safe for you to make a departure. So all intersections must either be stop or signal control. Dua ni lah. Either stop or signal control. If it is not viable, then you need to opt for interchange. So this is the side triangle that is used in a intersection design. So this person over here must be able to see the other person, okay? And this is the stopping side distance. So the H2 for this design, H1 is same with the previous one lah, 1 meter plus 1.15. But H2 here is 0, meaning that the driver must be able to see the pavement on at the intersection. Should be able to see the pavement. Okay. So the H2 is 0. Any object within the side triangle high enough above the elevation of the adjacent roadway should be lowered. So anything that hinders the view over here should be eliminated. Such objects include flat slopes, tree bushes, and others lah. This also requires the elimination of parking within the side triangle, meaning that there are no parking should be allowed here. Okay. So this is according to Osroads 2009. They have a little bit complete but slightly excessive measurement of sight distance for in intersection areas. So the first one is approach sight distance, okay, ASD. Okay, so this is the distance for this driver on the minor road where it should be able to see the pavement and stop lines, everything here on the in the area of the intersection. So this is also H1, H2 is 0. So this person over here must be able to see the pavement and the lines. ASD is the minimum level of sight distance which must be available on the minor road to make sure that the drivers are aware of the presence of an intersection. Okay. The criteria for ASD is similar to SSD, but object is measured to 0 object height. ASD, yeah. So ESD is the entering sight distance required for the driver to observe a safe gap in an uncontrolled traffic flow. Okay. ESD is the sight distance required for minor road drivers to enter major road via left or right turn, such that the traffic flow of the major road is unimpeded. Okay, going back to this measurement. So this is ESD distance. So at this distance, this car over here stopping at the stop line must be able to see the gap here between these two vehicles. So they must be able to see the gaps so that to ensure that they can make a safe departure into this other lanes, okay, into the major road. So the distance is ESD over here. But Oslo 2009 has not included any ESD because it is found to be impracticable. Maknanya dia ada in theory je lah. Okay. The most important part is this lah. Safe intersection sight distance. Sama juga. Distance dia dekat sini. Okay. So, mana tadi? Main road drivers. Dia kata daripada sini pula. So now yang ni main road drivers must be able to see vehicles on the minor road. Jadi dia cakap daripada sini must be able to see the gap on the major road. Tapi SISD ni, drivers on the main road will have sufficient sight distance to an entering vehicle kat sini. Sight distance, dia nampak. This guy must be able to see the vehicle waiting at the stop line. Okay. Jadi, to enable them to avoid collision if the side road driver enters the intersection with insufficient gap in the priority stream. So, if by chance this driver here decided to cross, so the time taken for this vehicle to reach is more than enough because it is longer than this SSD distance. Okay. So the sight distance is measured from the position of the vehicle waiting to enter a major road here to a vehicle approaching the intersection in the major road over here. Okay. So this is viewed as a cross section, bukan long section. Long section of the minor road and cross section of the major road. Sorry, terbalik. Long section of the major road, cross section of the minor road here. Okay, so this is ESD, ASD, SISD, and this is ASD. So this is vehicle height, and the height here is 0. H2 here is 0. It must be because the driver should be able to see the road line painting on the surface of the pavement. So these are the values. Normally we'll just use this one lah. Intersection sight distance here, SISD, safe intersection sight distance. So for let's say 80 kilometers per hour design speed. For urban area, the SISD is 165 meters, something like that. So compare with JKR, AT, ini signal kan, kalau stop control 170 meters kat sini. Okay. Oh, saya dah letak balik kat sini. Okay. Sightlines and visibility to traffic signal and signs. This important traffic management. These important traffic management items need to be visible to approaching drivers sufficiently far ahead. Okay, meaning that it should be high enough lah. If you just follow the specification, what the specification requires, there'll be no problems with the visibility, kan? Provided that the alignment is correctly done, the vertical alignment, so you'll be able to see signages. For traffic signs, the visibility distance necessary is dependent on the offset from the traffic lane. How far is the signboard from the traffic lane? The number of words, symbols on the sign face, and height and lettering of the speed of traffic. This will be covered, I think, next week. Okay. So there's also interchange sight distance. This is just to give you some idea lah. Entry or merge sight distance of the vehicles coming here and going down must be able to see the other vehicles on the main flow, for example. This one also must be able to see approach sight distance. Okay. So right turn lanes, improve capacity. We need to provide right turn lanes if the major flow of the road, major road flow exceeds 300 vehicles per hour. Okay. So right turn lane must be provided if the flow of the major road is more than 300 vehicles per hour. At all intersections on divided urban roads, sufficiently wide median. If you have a wide median, then you need to have right turn lanes. At all intersections on undivided urban roads where right turning is likely to cause unacceptable congestion of hazard. Meaning that if you don't have this, you only have normal lane, and then you provide the normal lane for right turning only, it will result in congestion. Okay, then you need to have right turning lanes, dedicated right turn lanes at all rural intersections in the interest of safety. Normally, rural, we don't have problems with space. Then, better to have a right turning lane. So the length of the right turning lane depends on the average number of right turning vehicles, N. And S is the headway in distance. Headway is the distance between the front of the first car and the front of the coming car, the second car. So this is the headway and this is the gap. So what matters is the headway lah for the design. So S is normally we take it as 6 meters for passenger car. For commercial vehicles is 12 meters. Okay. If the commercial vehicle ratio is not known, 7 meters of S should be can be used. Okay. N times S. Average number of right turning vehicles, ratio S apa tu? Average headway. So that is the storage length. Length of right turn lane for unsignalized. Tadi tu signalized. So, okay. 2 times M times S. M is the average number of right turning vehicle and S is the spacing lagi lah tadi, the headway. At both signalized and unsignalized intersections, storage length should be at least 20 meters. Kalau tak ada 20 meter ni tak payah letak. Okay. Because dia akan lebih menyusahkan lagi. Okay. Kalau ada mesti at least 20 meters. Should be provided if the right turning vehicle volume for the above collision is not available. a right turn lane shorter than the required would cause the turning vehicles to follow up on the parallel lane and to obstruct through traffic. Macam ni lah. You provide too short, less than 20 meters. So it results then the spill of queuing vehicle into the major lane. So that will obstruct traffic. Might as well don't have it. Okay. Right turn lane shall desirably be 3.5 meters wide and should not be less than 3 meters wide. Okay. Kat sini lah. Sini, sorry. Right turn lane. Minimum 3 meters, desirable 3.5. So this is right turn lanes punya specification. The length of the deceleration length, LD, over here, and LR. Ni tak apalah. Left turn lanes pula. Left turn lanes, the type of left turn lanes and treatment depend on volume and type of traffic making the turn. The restrictions caused by surrounding development and speed to which the left turn is to operate. So we normally assume lah the left turning speed. You see afterwards. Why do we need to assume this speed? People left turn ni tak payah kot, boleh baca je lah. They are usually provided where traffic volumes are very low and land acquisition costs prevent more extensive treatment. Very expensive land. Okay, so you only can afford simple left turn. Urban intersection, the radius of the curb for left turn should be a minimum of 6 meter. Radius turning dia mesti at least 6 meters. This allows most commercial vehicles to negotiate turn at low speeds. While radius larger than 10 meters increase the speed of turning movement, they can reduce the safety of pedestrians. Although we would like to have, it's good, seemingly good to have larger turning radius for tight urban areas, but it is advisable not to have it larger than 10 meters. Because if you have larger than 10 meter radius, vehicle will take the turn at a higher speed. Sorry saya ambil ubat sekejap. Okay, so vehicles tend to take the turn at a higher speed. Therefore, it will reduce the safety for pedestrians. Okay, separate left turn lanes. Design of left turn lane shown in table 3.2. Okay, so it depends on the design speed of the approach road. So this is the design speed for the turning lanes. If the approach road, for example, the design speed is 60, then the turn lanes of the minor road should have the design speed of 30, something like this. So the width depends on the category of road and area. So W3 over W1. There's a diagram here. 3.13. Okay, sekejap. Okay. Where radius is more than 45 meters, this is not this is larger lah for apa tu, higher standard road, higher hierarchy roads. R1 mana? Minit anak saya pula. Okay. Okay, saya dah lupa pula ni sekejap. R1 12 meters to 30 meters. Sekejap saya nak kena ingat semula. Where R1 kat sini. Okay. Kita tengok design ni dulu. This is R1, this is R2, and this is R3. And this is W, the width. So this type of left turning lane, not lane, left turning betul lane lah. Left turn lane will have 3 radius. Radius 1, radius 2, radius 3. And this is the W. Where R1 is between 12 to 30 meters, R2 must be 1.5 times of R1. So it depends. So 30 meters times 1.5 is 45 meters lah. So it depends on the width of the length of R1. Where R1 is 30 to 45, R2 is twice R1. So if R1 is 30 meters, R2 should be 60 meters radius. If R1 is more than 45 meters, single radius is acceptable, meaning that the entire curve here consists of only one radius. W1 is for single lane flow over here. So if radius 1 here is 12 meters, for example, W1 is 6.5 meters if you want to provide for single lane flow. If you want to provide for W2, single lane flow with provision of a stop vehicles, meaning that one vehicle pancit ke boleh can park at the side of the road. So you must allow 7.5 meters width. Two lane flow. Two lane flow is W3. Okay, you want to allow 2 lane, then W3 is 10.3. This is for R1 is equal to 12. So it is charted here, tabled here. R1 from 12 to 150. Okay. So this is the what we call as taper. There is no extra lane here. It's just a taper from this point to this point. It is just a taper. So this is the minimum treatment, and this is the desirable treatment. Type A. Okay. Let's go into taper. If you are using the design that I've shown you just now, you have only tapers over here. This is the taper, meaning that you don't have any extra lane. Your road has 2 lanes on one side over here, and you enter the left turn lane here, okay, using the taper. Okay, and then you exit that lane also using this taper. So shared entrance and merge exit over here. For this type of design, you're going to have a parallel segment. So this is the taper, and you have a parallel segment over here. This is known as auxiliary lane. Okay, for this on this side, this auxiliary lane is known as deceleration lane, meaning that you decelerate to slow down so that you can take this curve. Okay, and on this side is the acceleration lane, and here is the parallel part, and at the end here it must have another taper like this. Okay, you have another taper. So the length of taper, TD and TM. So it depends on the design speed. and the YD, lateral deflection of diverging traffic. Normally, this is the width of the main road, main lane. Okay, main road, the width of the lane lah. Okay, and minimum length of pavement taper for this is the length of taper, and this is the width of the lane. Okay, so if you are moving from the middle of this lane to the middle of this lane, for example lah, so assume that the distance, the lateral movement is another lane, one lane. So if the width of this lane is 3.5, then the lateral movement is also assumed to be 3.5, more or less lah. Okay. So V over 3.6 times YM, lateral deflection of merging. YD is for diverging, YM is for merging. So this is one how it should look like lah. If only you have a taper, then you have TM here and TD. So this design, this is just sharp, sharp lines. Okay, or you can have a curve here where this is the IP. You fit in a curve over here, you fit in a curve over here. Okay, straight with reverse curve. So one curve and another curve. So that's reverse curve. Straight with a single curve. Satu curve saja kat sini. So this is alternate auxiliary auxiliary lane taper. So you have a taper and you have a parallel segment over here. Okay. So it depends on the space that you have lah. How much space do you have and how much volume of traffic. But if you have the space, might as well you do this auxiliary lane lah, provide, because it is safer. Okay. So auxiliary lane, deceleration lane. So this I already explained to you just now. Deceleration movement separated from the two traffic stream. So this is the length of the deceleration lane. Design speed of approach road. Let's say the major road lah. Major road is 80. Design speed of the exit curve. We normally take between 20 and 30. So the length is going to be 104 meters. Okay. It doesn't seem much, but if you try to put it in practice, this is quite a lot. And this is deceleration. It's shorter than acceleration. Acceleration, the length is going to be longer. Okay. So this is the standard taper. If it only consists of taper, this is TD. If you're going to have a parallel, then you should have a parallel where this is TD divided by 2, TD divided by 2. Okay. Length of parallel, complete vehicle. Tak apalah, ni boleh tengok that figure. And this is this acceleration lane. Okay, same with deceleration lane, but the value normally is longer. So you can see here design speed 80, exit speed let's say 30, so the length is 200 meters. Okay, 200 meters is very long. Okay. So this is the example. You can see this is the auxiliary lane, deceleration lane, and this is the acceleration lane over here. Same here. Deceleration, and this is connected. So you can see it is definitely non-standardized. Again, you have to depend on your creativity and make sure that your creativity is in line with safety. Okay. Okay, so these are just for your knowledge lah. Types of grade separated intersections. You have trumpet configuration, three-leg, diamond, cloverleaf, full cloverleaf and partial cloverleaf. Okay, so you can see here, I took these pictures normally from areas inside berjaya. So this is full clover leaf. Okay, full clover leaf. So full clover leaf combined with apa tu? Roundabouts and very special designs. So this is almost a clover leaf. Almost a clover leaf, but not quite, because this part is already occupied by housing. If you have this much space, then it's not much of a problem lah, dealing with new development. The problem comes when you are dealing with existing development. Okay, single point diamond. Oh no, this is single point urban interchange. Okay, diamond, all directional 4 leg. Betul ke? Macam bukan je. Boleh kata lah, tapi dia ada macam roundabout sini kan. Trumpet. Ini mana satu all directional 4 leg ni? Yang ni lah kan? This one. Okay. Ini pula. Wallahu alam, saya pun tak tahu. So depends on the space and depend on creativity and depend on safety lah. Ultimately it depends on safety. Okay, if you have the space, no problem. You can construct anything you like. Okay. Any questions? All right. Okay, if there's no question, then I'll end the lecture here. Thank you very much. I'm thinking of having a test, but cepat sangat kawan awak left ni. Saya belum sempat cakap pun. Maybe next week lah. But your test is going to be open book. Okay, it's just theory. I'll inform your class rep. I forgot who's the class rep actually. I'll inform somebody from the class lah to pass the information about the test. The test is only going to take about 1 hour, and it is open book. You can submit the test after the class. Upload in Spectrum. Okay. Thank you very much. I'll see you next week.
Thank you, Doctor.
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 Guys,
Thank you,
don't forget to scan your attendance in Spectrum.
All right, Doctor. Thank you.
All right, Doctor.
Welcome.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Welcome.